Hello everyone, I am Dr. Kavita Gajvi, Assistant Professor, Pune College of Pharmacy, Bharati Vidyapeeth, deemed to be University, Pune. So today's my topic for the presentation is stability of emulsion. So first of all, what is the meaning of emulsion? Emulsion in physical mixture of two or more liquid in which one is present as a droplet of microscopic or ultramicroscopic size distributed throughout the other. That means we can say the one phase is dispersed phase and another phase is dispersion medium, or dispersed phase, which is also known as the discontinuous phase, and dispersion medium, which is also known as the continuous medium. An emulsion is said to be stable if it remains as such after its preparation. The dispersed globules are uniformly distributed throughout the dispersed medium during its storage. That means emulsion is stable for a longer period of time, and when it prepared by using or by maintaining all the criteria or parameter which is actually suitable for preparation of emulsion. The emulsion should be chemically stable and there should not be any bacterial growth during its shelf life. So what are the major three changes arise while storage of emulsion? As our topic is stability of emulsion, so we will focus basically on the stability issues arises during the storage of emulsion. So first issue is cracking, second problem is creaming, and third one is phase inversion. So here in this diagram, you can see, in first diagram, you can see if we start with the emulsion. So this emulsion seems like a stable emulsion because the dispersed phase, which is distributed throughout the dispersion medium in a continuous manner or in a suspended manner. But if we will store the type of emulsion which is not prepared by considering all the parameters, for example, all the climatic condition, pH, or if we add some kind of monovalent emulgent in a divalent kind of emulsion, or vice versa, or maybe due to the decomposition of emulsion, if we keep for a longer period of time, or we can say it also depends upon the radius or also depends upon the viscosity of both of the medium. So it shows some kind of stability issues like breaking, which is also known as the cracking, and creaming, and also the flocculation means the conjugation or aggregation of these dispersed phase particles, and coalescence also. After some time, that flocculation leads the coalescence process because these particles may form more bigger aggregates or floccule molecules. So here in this second figure, you can see emulsion, and it start the flocculation process, and after some time it can convert into the creaming process. So deposition of these floccules over the surface, over the bulk solution, and it leads or it facilitates the process of breaking, or we can say the cracking, which is irreversible process and more difficult or the tedious process. And after that, you can see if the directly coalescence formation occurs, so coalescence also leads to the breaking process or cracking of emulsion. So what is actually cracking? This is our first problem. So cracking means the separation of two layers of dispersed and continuous phase due to the coalescence of dispersed phase globules, which are difficult to redisperse. And the cracking is due to following reasons like addition of emulsifying agent of opposite type, decomposition or precipitation of emulgent, addition of common solvent, microorganism growth, change in temperature and itself creaming. So here addition of emulsifying agent of opposite type. If Soap of monovalent metal produce oil in water type of emulsion, whereas soap of divalent metal produce water in oil type of emulsion. But the addition of monovalent soap to a divalent soap emulsion or divalent soap to a monovalent soap leads to the cracking of emulsion. We can say just opposite kind of soap addition or divalent or monovalent soap addition leads to the process of cracking. Decomposition or precipitation of emulsion. When an acid is added to an alkali soap emulsion, turpentine liniment, for example, it causes the decomposition of an emulsion and thus leads to the cracking of the emulsion. When sodium chloride are added to sodium or potassium soap, which leads to precipitation of emulsion and cracking of the emulsion. So these two are the example comes under the decomposition or precipitation process of emulsion. Now, addition of common solvent. When a solvent is added onto the emulsion, the solvent may be miscible or dissolved. The emulgent or dispersed phase or continuous phase lead to the formation of clear liquid or solution, which leads to the cracking of emulsion. For example, addition of alcohol to turpentine liniment cause cracking issues. And one more reason, like microorganism growth, if emulsion are not stored properly, which leads to microbial contamination onto the emulsion, and hence microbes get deteriorate the emulsion and lead to cracking of the emulsion. So use preservative to prepare or to preserve the emulsion properly and prevent the microbial growth onto the emulsion for a longer period of time. Change in temperature. Yes, this is also one of the biggest issues or biggest problem in case of cracking process. The high temperature leads to decrease the viscosity of emulsion and cause creaming and get deteriorate. While stored in cool or freeze condition leads to formation of ice of dispersion medium, leads to cracking of the emulsion. And similarly, one more reason, creaming itself. Creaming creaming process of emulsion are more rapidly cracked than other emulsions. Now, second problem is creaming. So what is actually creaming? Creaming may be defined as the upward movement of dispersed globules to form a thick layer at the surface of the emulsion. And creaming is temporarily phased because it can be redistributed mild shaking or stirring to get again a homogeneous emulsion. As far as possible, creaming of an emulsion should be avoided because it may lead to cracking, which completes separation of two phases. Or we can say that creaming is the reversible process, but cracking is not a reversible process, and it is very much difficult to regain the consistency of the emulsion if emulsion cracked or braked properly. According to the Stokes law, rate of creaming are dependent upon the number of factors are following. This is that one of the formula V is equal to 2R squared in bracket D1 minus D2 into G and divided by 9 eta. So where V is the rate of creaming, R is radius of globules, D1 is the density of dispersed phase, and D2 is the density of dispersion medium. G is gravitational constant and is viscosity of dispersion medium. So what are the reasons behind the creaming? First one is radius of globules. As per the Stokes law, the larger size of globules, the rate of creaming is faster than that of small size of globules. Once the size is reduced, then the creaming can be minimized. So this is also one of the solution how to overcome that creaming process. Different density of dispersed phase and continuous phase. As per the Stokes law, once the density difference between the dispersed phase and continuous phase is increased, which leads to higher the creaming rate. And another, viscosity of the dispersion medium. As per the Stokes law, viscosity of medium are inversely proportional to the rate of creaming. So we can manage by managing the viscosity of dispersion medium. Storage condition, the rate of creaming is also dependent on the temperature of storage condition. So yes, that parameter or that reason we have already taken in case of cracking process also, because temperature reduce, temperature itself increase, the viscosity of the dispersion and dispersed phase goes. So it is very necessary to maintain or to balance the viscosity of both of the medium for proper consistency and for proper storage and for proper that manageability of emulsion system. And third issue or problem is phase inversion. It means change of one type of emulsion into the another type. For example, oil in water emulsion changes into the water in oil type of emulsion and vice versa. So here in this representation, you can see our continuous phase is pure oil, and when we add starch dissolved in water and when we add in the pure oil, so it forms a kind of dispersed phase or kind of globules which disperse throughout the oil medium. So you can see in this representation or in this diagram. And here in third process, you can see here the formation of water in oil type of emulsion and water in oil type of emulsion. But when we add in a excess amount of this dissolved starch in water, so it convert into the oil in water type of emulsion. Okay, so this is a kind of phase inversion which occurs after the or due to the excess addition of any phases into the another phase. And why phase inversion? Because of the addition of electrolyte, because of changing the phase volume ratio, and by temperature changes and by changing the emulgent property. So here, if we see the solution to overcome creaming, solution to overcome coalescence and breaking, and solution to overcome the phase inversion. So here, few of the solutions, like in case of creaming, first is make dispersed particle homogenized. If particles are in proper shape or in proper size, so there will be no chances or less chances of creaming process or formation of flocules or aggregates. Reduce particle size of dispersed particles. Yes, the dispersed particle size must be less or in a reduced or in uniform shape or size. Make densities of both the phases equal, like 50 is to 50%. So 50 is to 50 ratio. So it this will be the good criteria to maintain the cream, maintain the emulsion consistency. Increase viscosity of the dispersion medium. Yes, this is also one of the point which include under the overcoming process of creaming. And now after that, how to overcome breaking? Determine the phase volume ratio. What is the phase volume ratio? This is very necessary to determine or to know initially. And increase in zeta potential. Yes, if zeta potential is increased or it is not very less, so it also maintain the consistency of emulsion. And decreasing the interfacial tension using a good emulsifier. Yes, obviously for reducing the interfacial tension, it is very necessary to use a good kind of emulsifier which maintain the property of emulsion. Yes, the solutions to overcome phase inversion problem. So reduce the density difference between the two phases, dispersion medium and dispersed phase. Reduce the droplet radius, coupling with a narrow droplet size distribution, and increase the continuous phase viscosity. Yes, now I am coming to the point after finishing what kind of problems arises in case of emulsion stability or how to overcome that stability issues. Now I am coming to the point what kind of test method is suitable for checking, for evaluating the emulsion properties. So first of all, we should know about the pH that we can observe by using pH meter. We should know about the viscosity. So rotational viscometer we can utilize to check the viscosity of our emulsion. flow behavior, oscillatory, shear viscosity with a cone or plate geometers that we can use, texture that we can check by extensional and compressional deformation process. Color visually we can observe or by using colorimeter. Order, organoleptic order must be there, that we can say taste, flavor, or appearance. It should be proper or adequate. And specific gravity psychometer, a separation creaming value, and visual or instrumental method also utilized for checking the separation process. Conductivity. So conductivity meter is very good to check the conductivity of our emulsion. Droplet size distribution, microscopic examination is the good technique to know what are the size of particles or droplets which is present in the continuous medium. Or image analysis or any other instrumental technique also we can utilize. And preservation, yes, good good preservatives that we can use, which reduce the challenges associated with the microbial growth. And the microbial assay also we can perform to check or to know the species and to know the extent of microbial growth in a particular kind of emulsion. Vibration shipping test or shaker tables generally useful. Active ingredients like chemical or bioassay that we can use or check the property of active ingredients. So now what are the containers that we can utilize for storage or for proper packaging of emulsion? So it should be packed in a container having an adequate air space above the emulsion so as to permit adequate shaking before its use. Yes, generally this is the indication or direction. It should write over the label of emulsion bottle, and generally you have seen in your in marketed formulation also. So this is the kind of direction, shake well before use. So that's why it should be it should present a proper space for proper shaking of the content which is present in the bottle. The emulsion which are meant for internal use should be packed in comparatively wide mouth bottle so that it is easy to remove it without any difficulty. Metallic closure should be avoided because it may cause some kind of deterioration and some kind of reaction between the active pharmaceutical ingredient which is present in the emulsion formulation. Wide mouth amber colored glass bottle are most suitable for the storage of emulsion. Now, what is the proper labeling condition? A secondary label or that we can say the shake well before use is required to be fixed on the container. And primary label, another kind of indication like for external, for internal use or for basically for what purpose that we can write. Storage and emulsion should be stored in an airtight container, protected from sunlight, freezing, and high temperature. Emulsions are required to be stored in a cool place. And few marketed formulations of emulsions. So drug is propofol and brand name is Diprivan, and it is useful for anesthetic condition. Drug is dexamethasone and brand name is limethasone, and as a steroid that we can use. Fluoroprofen, Exetil, Ropivon is the name of that emulsion, and non-steroidal analgesic preparation. Vitamin A, D, E, and K, beta lipid is present in as a marketed formulation, and it is useful as a parenteral nutrition. So all these are the references of this content. Thank you so much.